Hello guys, so I welcome you to the lecture 8 of this series on binary heap. In this lecture, we are going to talk about build heap operation. Okay, so how a build heap operation works on uh, a min heap and on a max heap. Okay, so we'll talk about this build heap function. Okay, but before that, let's talk about why we need this build heap function. Okay, so we already knew that there are sometimes there are some violations in the binary heap. Okay, so let's talk about the violations. Okay, violations. Okay, I don't know whether the spelling is wrong or right. Yeah, so let's say we have a min heap of size 5. Okay, so size of the min heap is 5. Obviously, as you can see, there are 5 nodes. Array representation would have 5 elements, and the elements are this way. Okay, so let's say that we are talking about min heap right now. Okay, so min heap should have smallest element at the top. Okay, so let's say the element here is 5. Let's say 3 is here. Let's say uh, 9 is here. Let's say 11 and 13 is here. Okay, so there is a violation within this particular these two levels. Okay, what is the violation? That this 3 should come at the top and this 5 should be at the position of 3. Okay, so how the heap actually should look like? It should look like this. Okay, so okay, so the heap should look something like this. Okay, so this 3 should be here, 5 should be here. Okay, 9 should be here, 11 and 13. Okay, this should be the actual the correct value, correct positioning of each value. Okay, yeah, now but this is not a min heap. Okay, this because the child has a value smaller than the node itself, so this is not following the min heap property. So how we are, this could be fixed by simply passing the index of the root. Okay, I equals to 0 we pass into the min heapify function. Okay, min heapify function. Okay, because there is only single violation, min heapify 0, so it would fix this thing. Okay, but let's say we have multiple violations within a heap. So in case we have multiple violations, let's talk about multiple violations. Okay, so let's say we have a min heap like this. Okay, so we have a size 5 sized min heap, and it has elements this way. Okay, so it has 7 at the top, then it has minus 4 here. Okay, then it has 5, then it has minus 9, and then 11. Okay, now this is not a min heap, since not every node has the uh, value of the child's smaller than the node itself. Okay, you can see in the first two levels here. Okay, uh, the value of the node, root node is 7, and the value of its childs are minus 4 and 5. Okay, yeah, so there is a violation. This minus 4 should be at the top and 7 should be here for the first case. Okay, but even if the 7 comes here, still there is a value minus 9 which is smaller than the value 7. So 7 should go to the place of minus 9, and then minus 9 should be at the topmost place and minus 4 should be at the second place. Okay, so these two should be swapped. Okay, in order to get the correct max heap. Okay, so how this max heap should actually look like? Okay, yeah, so this it should look like this. Okay, so at the top there should be minus 9. Okay, and at the you know at the index 0 1 2 3, at the index 3 we should have 7. Okay, I equals to 0, I equals to 1, I equals to 2, and I equals to 4. Okay, here at this index we have minus 4 only. Okay, 5 and 11. Now it is perfect. Okay, so minus 9 has a value smaller than minus 4 and 5, and minus 4 has a value smaller than 7 and 11. So this is the correct max heap, where this is not a max heap, and there are multiple violations. Okay, multiple violations at different levels. There was only single violation, and if we change that, if we fix that, the heap would change, right? But here we have to perform multiple, we have to fix multiple violations. So in order to fix multiple violation, we use something called build heap. Okay, what do we do? So it would be a void function, since it is not going to return any value. Okay, build heap. Okay, let's say in case of min heap, we call it min heap. Okay, we call it build min heap. Okay, let's call it this. Okay, build min heap. We are not going to pass anything. Now what we are going to do, the structure of the function looks something like this. So for int I becomes equals to size minus 2 divided by 2. Okay, I is greater than equals to 0. Okay, greater than equals to 0. Let me move it a little bit. Okay, uh, I is reduced each time, and inside it we'll call min heapify function. Min heapify function. We are building min heap right now. Okay, therefore we are calling min heapify function. Okay, yeah, this way, and this would fix the heap. Okay, this would fix the heap if it has more than one violation. Okay, so this heap, okay, this heap would be converted into this one. Okay, so what are we giving it in the input? So this is index 0, this is index 1, this is index 2, this is index 3, and this is index 4. Okay, and the heap we are getting is this one. Okay, so input of the min heap would look something like this: 7 minus 4 5 minus 9 and 11. Okay, while in the output we are getting minus 9 minus 4 5 7 and 11. Okay, this we are getting as the output. Okay, uh, now let's try to dry run the code. Okay, so we already know how min heapify function works, right? We already know how it works. So let's try to work with this. Okay, how it will fix the multiple violations. So let me draw the heap again. Okay, so my 7 minus 4 5 minus 9 11. Okay, let's say, okay, let's say this is the heap. Okay, yeah, so 7. Okay, let's move minus 4 5. Okay, so minus 4 5 minus 9 and 11. Okay, now what you're going to do, let me write the index as well. I equals to 0, I equals to 1, I equals to 2, I equals to 3, and I equals to 4. Okay, this is minus 4. Okay, this is minus 4. Okay, now what happens is that we call the for loop from this index. Okay, so the size is, we know the size is 5. Okay, because there are 5 elements. So what we do, size is 5. Okay, we start the loop from uh, 5 size minus 2 divided by 2, which is going to be an integer division, right? 3 by 2, which is going to be 1. Okay, so we start from here I equals to 1, and we reduce each time till I is greater than equals to 0. We reduce the index each time, and we call min heapify function. Okay, within there. Okay, so what happens is that when we call okay, so it will run from I equals to 1 to I is greater than equals to 0. Okay, greater than equals to 0, and each time we reduce it by 1. Okay, yeah, so let me write the, you know, let's try run the code. Okay, so first case will be for I equals to 0. Okay, for I equals to 0, when we call build heap function. Okay, in case of I equals to 0, sorry, I equals to 1, not 0. Okay, yeah, so this would be 1. Okay, now for I equals to 1, when we call build heap function, what happens is that uh, sorry, we call min heapify function for I equals to 1, right? So when we call min heapify function, we already know we'll find left and right. Okay, if you do not know how min heapify function works, you can look at the previous lecture. Okay, I've taught about, you know, the working of min heapify function. So left will be 1. Okay, this is not index. Okay, we will pass index also. So here index will pass as I. Okay, I itself. Okay, so left has index 1. Sorry, index is passed as I. So I for the first case was 1. Okay, so left of 1 is going to be 3 and not 1. Okay, so let's erase it. It is going to be 3, right is going to be 4. Okay, now we will use two. Okay, we will use two conditions, right, to get the smallest. So smallest that we'll get is this one. Okay, because this has the smallest value. So yeah, so this has the smallest value, so we'll get minus 9 here, minus 9. Okay, but in this case, this is the value, right? This is the smallest value and not the index. So in smallest variable we'll store the index is 3. Okay, now what we'll do, smallest has changed now. Okay, we'll swap. Okay, so after performing operation on this heap, the new heap that we're going to get is something like this. Okay, is going to look something like this. Okay, so 7. Okay, Yeah, so it would look something like this. 7 would be here, there would be minus 9 here, okay, then minus 4, then 11, and then 5, okay. Yeah, so after performing min hippify for I equals to 1, okay. Now min hippify for I equals to 1, okay. Now if we call min hippify for I equals to 0, because now the value reduces, right? Now the value is reduced by 1, so and then after I equals to 0 the loop will terminate, okay. So the second condition is when the build heap function runs for I equals to 0, okay. Now in this case the left becomes 1, right becomes 2, okay. 0, this is index 0, right? The left of index 0 is having index 1 and right is having index 2, okay. Now smallest will be out of these three, okay, out of, sorry, this was the new heap, right? I equals to 0, I equals to 1, I equals to 2, I equals to 3, and I equals to 4, okay. So this was the new heap, right? So the left is minus 9 and right is 5, so smallest is this, right? This is the smallest value out of these three, okay. This three, the index 1 is having smallest value, so we will store smallest as 1, okay. Now we, what we do, we swap, okay. So we swap after, you know, after swapping, what we get is we get a new heap, okay, because the value of smallest is changed, right? Earlier it was 0, but now it became 1, okay. So min heapify after, after this call min heapify 0, what happens is that the new heap that we'll obtain will look something like this, okay. Okay, let me move it a little bit. Yeah, so it would look something like this, okay. The values will be minus 9 here, okay, because they are swapped, right? 7, 5, minus 4, and 11, okay. And now min heapify is called for index 1, because index 0 and 1 is swapped. Now we will call it for 1, okay. Min heapify for index I equals to 1, because this was having index 0, this was having index 1, this is index 2, this is index 3, and this is index 4, okay, equals to 4. Now min heapify is called for this particular index, okay, index 1. So the left will be 3, right will be 4, smallest will be, okay, out of I and left and right, okay, out of these three the smallest is minus 4, right? Smallest value, so it is having index 3, we are going to store the index of it, okay. Now smallest has changed, so swapping again takes place, okay. Swapping again takes place, okay. So we are going to erase it, okay. Wait, so we are going to erase it, okay. Swap occurs between these two elements now. So the new min heap that we are going to get is going to look something like this, okay. After the min heap operation, it would look something like this, okay. Minus 9, 7, sorry, not 7 actually, minus 4 comes here, right? 7 goes to the place of minus 4, 11 and 5, okay. Now it is a min heap, okay. So minimum is at the top, the values of its child are both greater than minus 9 itself, right? So minus 4 is greater than minus 9 and 5 is also greater than minus 9, okay. In the second level also you can see here that 7 is greater than minus 4 and also 11 is greater than minus 4, okay. So this satisfies the properties of min heap. Hence, this is the final min heap that we'll obtain after fixing the initial min heap, which was this. Okay, this was the input, right? And in the array representation, the first heap that we were given was something like this, right? So let me write it down. Okay, so the earlier heap that we was having in the input, okay, the input heap was something like this, okay. So there was 7 at the index 0, 0, 1, 2, 3, 4, right? So 7, then minus 4 we had, okay. Here we have 5, minus 9 and 11, okay. This was the initial heap, okay. This was the input, okay. And the heap that we received in the output is going to look something like this, okay. So it is going to look something like this, okay. So let's say this is the heap, okay. So let's say these are the indexes 0, 1, 2, 3, 4. The heap is something like this. So at the 0 index we have minus 9. So this is index 0. I already told you this. Okay, index 1, index 2, index 3, and index 4. Okay. So minus 9, minus 4, 5, 7 and 11. This is what we are going to get after performing the build heap operation. Okay, now let's move to the Visual Studio Code and let's see how it works. Okay, so yeah, so I'm going to write another program which is going to be build heap build. I'm going to call it min heap. Okay, I'm going to call it min heap. Okay, dot cpp. I'm not going to write the whole code. Rather, what I'm going to do is I'm going to copy this. Okay, we are only going to implement the build heap function. Okay, so void. Okay, let me write the comment here so that you guys know. Okay, implementation of the build heap function. Okay, build heap function for the min heap to correct multiple violations. Okay, violations within the main heap. Okay, now this would be a void function, right? Void build, let's call it main heap. Okay, so inside it we are going to pass nothing. We are going to use the for loop for int I equals to size minus 2 divided by 2. Okay, I is greater than equals to 0, and I each time we reduce I by 1, and we are going to call min heapify function inside it. Okay, min heapify of I. Okay, this is what we are going to call. Okay, so I don't know why it is giving error to me. So it was not min heapify this way. Let's call it uh, min heapify. Yeah, this was the way. Okay, so I we are going to pass to it. Yeah, so now let's call it on min heap. Let's change the values. Okay, so we were having values like this: 7 minus 4 5 minus 9 11. Okay, 7 minus 4. Okay, 5 minus 9, and I guess 11. This is right. Let's check. Okay, 7 minus 4 5 minus 9 11. Yeah, and finally we are going to change the size to manually to 5, because now it has 5 elements and we are not using insert function to insert the elements, so the size will remain 0 only, and hence we have to increase it manually. Okay, now we are not going to use this, so let's comment it out. Okay, delete key operation. We are not going to use the for loop. Let's remove it. Okay, now what we are going to do is we are going to use build heap here. Okay, there are multiple violations within this heap, so we are going to use build heap. Okay, so this is not max heap actually. Let's rename it. Okay, okay, use let's rename it all at once. Okay, okay, so what we are going to do is we're going to reduce, call it min heap. Okay, because we are using build heap function for the min heap right now. Okay, let's change this as well. Okay, min heap. Now we are going to call build heap function on it. So min heap dot build heap. Okay, build min heap. Okay, we have called the build min heap function. Now let's try to print the array. Okay, so for int I equals to 0, I is less than the size will remain same, right? So min heap dot size. Okay, I plus plus. Okay, let's print min heap elements. Okay, min heap dot arr of I. Okay, let's try to, okay, this is not the function, so again let's remove this. Okay, yeah, so now the output that we need, that we are going to get is minus 9 minus 4 5 7 11. Okay, let's check. Minus 9 minus 4 5 7 11. So this is the output, as you can see. Okay, let's remove it once and let's try to run it again. Okay, yeah, so this is the output, and the input we have passed is the min heap that we have given here. Okay, so yeah, this is how a build heap function works in case of a min heap. Okay, now we are going to talk about build heap function in case of a max heap. Okay, how it is going to work? It is completely same. The only change that we have to do is within the build heap function. Okay, build, let's say we call it build max heap. Okay, this time, or let me just erase it and let me just increment, increase the size of this page, so that, yeah, now we are going to talk about max heap. Okay, max heap, inside max heap, how we implement the build heap function. Okay, build heap function. Okay, how this build heap function works in case of a max heap. The only change that we have to do is within the build heap function. Okay, void, let's say the name of the function is build max heap, build max heap. Okay, okay, we pass nothing here. We'll again use for loop for int I equals to size minus 2 divided by 2, okay, I is greater than equals to 0, and I each time is reduced by 1, and inside this we call max heapify function for the value of I. Okay, so we are calling max heapify, and that's it. Okay, so this is going to, you know, fix the violations within a max heap. Okay, let's take an example. Let's take an example here. Okay, let's take an example here. Okay, so let's say the heap, the heap initially looks something like just like this. Okay, something like this. Okay, so we have a heap of size 5. Okay, yeah, so this is a heap. Okay, so the heap looks something like this. So 3, 7, 5, and then let's say 6 and 11. Okay, so let's say this is how the heap looks like. Okay, initially, so I equals to 0, I equals to 1, I equals to 2, I equals to 3, and I equals to 4. Okay, now what should happen actually? Okay, so here we have 3 as the value of the root node, which is not maximum out of these three. So the maximum out of these three is 7. Okay, obviously. So 7 should come here, 3 should go to the place of 7, and 5, and then even in these three, okay, there would be 3, right? After, after calling, after fixing the first level, there would be something like this. Okay, so the heap would look something like this: 7, 3, 5, 6, 11. Okay, so this 11 should come at the place of 3, because this is the maximum out of these three, right? Out of these three, 11 is the maximum. So again, if we try to fix it, okay, again if we try to fix it, what happens? The heap we get is 11, 5, 7, 6, 11, 6, 3. Okay, now the problem is with this. Okay, this the first two levels, because 11 is the maximum out of these three, and 11 should go at the top. Okay, so finally the heap that we get after uh, three operations looks something like this. Okay, so it has 11 here, 7, 5, 6, and 3. Now it obeys the property of the max heap. Okay, now it has no violations. Okay, so 11 is the value of the root node, which is greater than both 5 comma 7, and then we have 7, which has value greater than both 6 and 3. Okay, so yeah, now this follows the property of a max heap. Okay, how do we get from this heap to this heap? Okay, we are again going to use build heap here, but here this time we are going to call max heapify function inside the build heap function, and we are going to create another function by the name of max build max heap. Okay, if you want to dry run the code, okay, you can just work as we did in the case of min heap. Rather, what you have to do here is that you have to move the maximum value upside. Okay, so 11 is more, greater than 7, so 11 will move to the place of 7. Swapping will be for the maximum element. Okay, and maximum element should be at the top. Okay, so now let's try to work with this case. Okay, let's try to code this in the Visual Studio Code, but let's just first write the input. So input heap would look something like this: 3 at index 0, 7, 5, 6, 11. Okay, and the output that we are getting is this, right? So 11 at the 0th index, 7, 5, 6, 3. Okay, now let's try to, code this in the Visual Studio Code. Okay, so let's create build heap function. Okay, so yeah, uh, what we'll do, implementation, okay, of the uh, build heap function for the max heap to fix, okay, multiple violations within a max heap. Okay, yeah, so void, it would be void function, right? Void build max heap, let's call it. Okay, build max heap. Okay, we won't pass anything here. For int I equals to size, okay, minus 2 divided by 2. Okay, is greater than equals to 0, I is reduced by 1, and we call max heapify here rather than min heapify. Okay, so we call max heapify, we give it value I. Okay, so yeah, this is how it is going to work. Now we are going to create a max heap here. Okay, let's comment this out. Okay, let's remove all of this because it is creating confusion now. Okay, so let's say static allocation object creation. Okay, let's create the object through static allocation. If you don't know what it is, you can watch my previous lectures on it. Okay, so let's say we are going to create a heap. Okay, let's call it max heap because it is going to be max heap, right, of size 5. Okay, now let's say max heap, okay, error of 0 equals to, okay, let's copy this. Okay, now this should have index 1, this should have index 2, this should have index 3, and this should have index 4. Okay, now the values of the indexes at the particular index are 3, 7, 5, 6, 11. Okay, so 3, okay, for 0th index, 7, then 5, okay, then 6, okay, and then 11. This is a wrong max heap and we have to fix it, right? So max, that let's manually give the size to the max heap. Okay, max underscore heap dot size equals to 5. Okay, now let's try to fix it. Okay, so we are going to use build heap function, right? Max heap dot build max heap. Okay, yeah, we are going to call it. And now if we try to print the size of the, if we try to print the uh, elements within the max heap, equals to 0, I is less than max heap, okay, heap dot size, okay, I is, yeah, so we are trying to print the element of the max heap, right, error of I, and yeah, something like this. Okay, okay, this shouldn't be a function, right, because this is a data member. Now if we try to print it, what output we are going to get? 117563. Okay, let's see if we are going to get this. 117563. Yeah, so it is absolutely correct. Okay, so that was it for the build heap function in case of the min heap. Okay, min heap and max heap. Okay, now we are only left with one particular thing, which is heap sort. Okay, heap sort function, and we are going to talk about how it works. Okay, it is the most important function. Okay, and it is kind of easy. Okay, in case you know how a build heap function works, and you know how a max heapify function work, it will be quite easy for you to understand build heap. Okay, so the prerequisite will be to understand the build heap and max heapify function, and that is it. Okay, you don't have to understand anything else. Okay, if you know these two functions, you will easily understand how a heap sort algorithm works. Okay, it is a very basic and very simple algorithm, or you can say a very simple algorithm to sort a particular array. Okay, sort an array. Why I'm calling it an array? Because you know the implementation of heap is in the form of array only, right? So yeah, that is it. Okay, so before you know moving on to this heap sort lecture, you must know these two functions. So if you revise these two functions, then it will be good for this particular lecture. Okay, so that is it for this lecture. Hope to see you in the next lecture.